So this rock I'm holding today in my hand represents life from billions of years ago. This is one of our ancestors, now fossilized and trapped in the rock. And today, we are here. I'm delivering a talk in front of you. But the question is, what brought us here? A journey which we all took billions of years ago. Today, each one of us here has an identity which differentiates us from others. And everyone on this planet at this very moment is identified as life on Earth. So talking about identity, we are also Homo sapiens. What speciality do we have is our innate curiosity. And this very fact sets us apart from the rest. So we can also ask ourselves a question of if life elsewhere in this universe would identify us differently, or even our own surroundings, plants, species, organisms which we see around us, see this planet in a different context, or see us differently. What we all share today, and for all that we have common, we call this place home. So, to begin with, I have an identity. I am identified as a geobiologist. And in the grand theme of our cosmos, what links my identity to this cosmos? As you can see, I was not born a geobiologist. But like everyone else, I was surrounded by nature and rocks. Growing up in the delta of Sundarbans in India, West Bengal, visiting my grandparents during the winter vacations, I was intrigued by the very fact of these roots. While playing, I wonder why they grew upwards. And this very fact caught me. This may have been my very first connection with geological as well as biological connections. And little did I knew then that a geobiologist was in the making. However, a pivotal moment in my life was nearly a decade ago when I visited South Africa and I met Professor Axel Hoffman. These rocks here, you see, are from the Barberton Mountains, one of those few places on Earth where you can study early Earth around 3.5 billion years ago. This amazing landscape hosts the earliest traces of life. And it was this meeting of mine with Axel that I decided to study these ancient mountains, which will unravel our past and our future. And I embarked on this journey. So as a geobiologist, you might wonder, what do I do? Let me introduce you to my world and share with you a few glimpses of my life. This photo is taken from the Daitari Mountains in India, where I did my PhD, and I mapped this ancient volcanic landscape. Rocks here date back to 3.5 billion years. I study ancient geological and biological processes which shapes our Earth. My job is to visit ancient mountains and hunt for rocks, look for the earliest life forms in them. My vacations are usually visiting ancient remote landscapes where I stand, crawl, and stumble upon rocks which are billions of years in age. And while doing that, getting chased by some elephants in some jungles of India. Through my comparative approach of geobiology, what I was able to establish is a narrative on the fact of early life from South Africa as well as India around 3.5 billion years ago and their environments. To do this kind of science, I've approached different toolkits as any other profession. This would include visiting the field, understanding the specific age of these rocks, and identifying biosignatures under a microscope, or even performing high-level, cutting-edge geochemical investigations. This has led me to unravel our past. And with this, I have established a global network of colleagues and collaborators, more friends, with whom I'm working hard to understand our volcanic and oceanic environments from the past. Remarkably, we have found similarities from India, South Africa, and Australia. Now, time immemorial, since the beginning of our origin, we have always wondered about our past and where do we come from. To understand our past, we have to unravel our humble beginnings, and it starts at the beginning of our solar system. At that point of time, physical laws were prevalent. Owing to condensation and accretion, those tiny cosmic dusts that you can see form a rocky mass. And this was our planet. A baby was born. At the initial stages of our Earth, it was still a hot, molten planet. Rocks of the earliest periods are rare to find, except for some mineral traces which are left behind. Although we are not sure of the science that we have done so far, the exact timeline when life appeared on this planet. But several million of 100 years into the Earth's formation, at some point, liquid water could sustain on the surface of our Earth. This was a vital moment, and it changed the course of our evolution, because of which we emerged, and this provided us to operate because water was a solvent. And to understand our past from such a blurry distance, we have to move into our Earth's history around 3.5 billion years, where the geologic record gets decent, and we can do substantial amount of studies. Now, in the spiral of our Earth's evolution, this would be deep down in this spiral. And that arrow indicates exactly where we should go to study this. To gain a perspective of this age is approximately, on an average human lifespan, in your mid-20s. I request you all now to spread the wings of your imagination. Our ancient Earth, around 3.5 billion years, was not the same as we have on our modern planet. It was an alien world where volcanoes were spewing lavas in those ancient oceans. And asteroid-sized objects were bombarding the Earth at a constant pace. Moon was much closer then. There was an absence of ozone because of a lack of oxygen in our atmosphere. There was a constant cover of envelope of toxic gases in our primary atmosphere. And guess what? We would have never survived this. But someone did, our ancestors. And in those oceanic environments, our first life forms evolved. This was the first time physical, chemical, and biological synergies were working together, providing the basic building blocks of life. For the first time, we had the emergence of life in those deep oceanic environments. This is an example to the right of a modern-day deep-sea vent, which is situated several hundred meters below the seafloor. And those black smokes that you see are mineral-rich fluids coming out of these chimney-like vents. This usually feeds the microbial community in the deep parts of our ocean today. And similar environment was there in the past. Now, the first life has emerged. And how do I know this? Because I get to study them. As a geobiologist, I study rocks. And I collect rocks which are of my own interest. And after having cut them thin so much so that light can penetrate through this slice of rock, I can usually study this under a microscope. And once I study this, it's always not a case that we would be lucky, but sometimes we get lucky. And one of these luckiest events was captured by some scientists. This is an example of one such morphological trace of life. It might look like a random bunch of needles haywire in this whole photo, but not. These are our ancestral microbial life, which are few micrometers in size. They are organisms which were in the past and now also on modern Earth. And ironically, these are tinier than our own hair follicles, 200 times. So this was the dimension of life. Till this time, on our Earth, there was no oxygen. And around 500 million years later, at 3 billion years, there was a major transition in our Earth's history. For the first time, in the shallow oceans, microorganisms such as this could grow and harbor life there. What it meant was there was oxygen available to the shallower oceanic mass, and oxygen was a key factor. This rise of oxygen in the oceans were prominent, and this changed the evolutionary course of our planet and us. Again, after 500 million years or so, there was a major jump or rise in oxygen at 2.5 billion years. And this event is globally known as the Great Oxidation Event. What we had is oceans and atmosphere with oxygen. And this very fact identified us today, what we are, giving rise to more complex life, multicellular life, and eukaryotes. And look at the diversity around us where you are sitting. This is because of those events in our Earth's history. Now, we are here, and none of us, including me, witnessed this journey of 4.5 billion years. But our Earth preserved these traces in the rock record. And today, with my identity as a geobiologist, I was able to present to you a few highlights of this aspect. We have learned that today, we are life in every sense, from the deepest oceanic environments to plants, animals, or even dinosaurs, which were in the past, and us. We are a journey of 4.5 billion years and a cosmic legacy. So as Homo sapiens, we identify us today with knowledge, consciousness, and technological advancements. Let us transcend a message for the future us, for the future generation. And one day, if we look up to the sky and seek for exploration elsewhere, let our identity guide us and evolve smart. Thank you. Dhanyavad. Siya Bonga.